So this is the first lesson of Chapter 11. The one was quite an important one. It refers back to Chapter 10 to remember important transformations for graphs. So I'm not actually going to go ahead and draw these, but the negative at the start of the question means it's a flip over the x-axis. Sine 2x is the one where the graph gets squashed in, so you manage to fit 2 times as many sine graphs as possible within the space. Plus 1 at the end moves the graph up one place, so that's a vertical translation. And the sine of x plus 90, with it being in parentheses, it moves it 90 degrees, but to the left, the opposite of what you'd expect. And cosine of x minus 180 moves it 180 degrees to the right. If you do try and draw these, then also an important property for the next section is even and odd functions. This one turns out to be an even function, this one turns out to be an odd function, this one turns out to be neither, this one turns out to be even, and this one turns out to be even. So if you have time, go back and draw those graphs and just confirm that you can agree with those results. Now this section today, what we're going to look at is composition of functions, and also domain and range, which is all topics covered in Algebra 2. So first of all, a bit about notation of functions for this. So we can either write it like this, or we can use the open circle, and both those things mean that we're going to be doing composition of functions. Now I put a little reminder here, when you're doing composition of functions, remember that you're going to work backwards. So if you're working f of g of 2, you take 2 and substitute it into g, and then you take that answer and substitute it into f. So you're actually going backwards when you're doing these questions. Now I've got a couple of examples to show that. So if we have a couple of functions here, f of x is 2x minus 1, and g of x is x squared minus 3. And if we're working out g of f of 3, what that means is we take 3 and plug it into f, take that answer, plug it into g. So if we plug 3 into f first, 2 times 3 is 6, take away 1 is 5, which is what I've set here. And then we take 5 and we plug that answer into g. So 5 squared minus 3 should give us 22. Now we can do this in reverse as well, so we could also find f of g of 3 rather than g of f of 3. So this time we take 3 and plug it into g. So 3 squared minus 3 gives us 6. Then take that answer and plug it into f. 2 times 6 minus 1 equals 11. As you can see, both answers are different here, so that shows you that composition of functions is not commutative. In other words, the order that you do this actually matters. Now you can also plug back into the same thing as well. So I can also ask you to do f of x, or if I give you a specific number, let's say 5. So you'd work out f of 5, 2 times 5 is 10, take away 1 is 9. Take that answer and plug it back into f. So 2 times 9 is 18, minus 1 is 17. Now more complicated is when you actually do this rather than having numbers, if we just have letters. So f of g of x means we take g of x and we plug it into f. So first of all we write down what g of x is, and I've changed the equations this time. So g of x is x squared plus 2. And then on equation f, wherever we see x, we write down what g was. So in other words, x squared plus 2. So instead of doing 3 times x minus 5, I do 3 times x squared plus 2 minus 5. So where originally I had x, I've written x squared plus 2. Then we go ahead and simplify. Now in reverse, g of f of x. So I take f of x first, which is 3x minus 5, and then I plug that into g. So x squared plus 2, wherever I see x, I'm going to write down 3x minus 5. So I'm going to do 3x minus 5 squared plus 2. Careful on this part, make sure you do FOIL accurately, and then go ahead and simplify. And there's one small mistake here. I should say plus 2, because it says plus 2 here, which means that should also be plus 27. Now you can do the same things with the same letters. You can have f of x and g of x, and if you want to pause the video and try those questions, then I'll reveal the answer in a second. So this would be f of x, and this would be g of x. And you could go ahead and work out what this one is as well. X to the 4th plus 4x squared plus 6. Now also there's a little practice exercise. The answers that you can see are at the bottom here. So you might want to pause the video and try these questions as well, just to make sure that you are getting the correct answers. Just to make you aware, there are a few things mixed in here. Rather than having x, I changed the variable to a. The first one's just have numbers. Also, we could just be asked to add the polynomials or subtract the polynomials, so it doesn't always have to be composition. We also have some of the different notations for composition as well, the open circle and without the open circle. And sometimes we could be asked to multiply by a constant and then go ahead and add the terms as well. And you can check those answers as well. Now also we're going to look at domain and range. So domain refers to all the x values you can have, and range refers to all the y values you can have. Now if we have a graph, this is very easy to work out. So if I said x squared plus 1, if we know the graph of x squared, then we know this just moves up one place. So my intercept here would be 1. Now I can take any number, square it and add 1, so my domain is all real numbers. Now you could also say it goes from negative infinity to infinity as well. That's another way you could do it. And you could use inequalities as well. You could say negative infinity is less than x, which is less than infinity. So 3 different ways you can do that. For the range, we can see the smallest value is 1, and then it just continues up forever. So y is greater than or equal to 1. Or you could say it goes from 1 to infinity. We've got brackets for the 1 because we're allowed 1. Infinity is not really a number, so we don't count that as a number, so we have parentheses for that one. 1 over x, this is the graph with the asymptotes. So we can have any value we like, but we can't have 0, because 1 divided by 0 is undefined. So you can just say x doesn't equal 0. You could also say it goes from negative infinity to 0, but doesn't include 0, so I've got the open parentheses here. And also it goes from 0 to infinity. Once again, it doesn't include 0, so I've got the open parentheses. And then we can use the union notation that you'd have seen in geometry as well to answer that question. But certainly that's a lot quicker. And for the range, same thing, as we've got a horizontal asymptote here, we have every value here and down here, but we just don't have 0. So we could use that as well to give our answers. Now, when we move on to the AICE questions, knowledge of graphs is going to be very useful. So we're going to do some composition of functions, because it says find the domain range of g of f. So we take f and plug it into g. So where we see radical x, we're going to replace x by that. So we get radical x minus 5. And this is where transformations comes in really useful. If you know the radical graph, which is this, then it's just moved down 5 places. And then we can start to figure out what we can have as our values. So you can see there's no negative values here, but we are allowed 0, so x is greater than or equal to 0. For our range, we can see the smallest value is negative 5, and it looks like our highest value here is like negative 2, something like that. You've got to remember this graph continues forever and ever and ever. In fact, if you were to plug a really big number in for x, say something like 1,000,000, then the square root of 1,000,000 will be 1,000, minus 5 is 995, and the bigger the number you choose, the bigger this number is going to be. So this is actually going to tend to infinity. So we can say y is greater than or equal to negative 5. Now we're starting to move on to the really complicated questions where we have several different things happening. So I got x squared minus x minus 6, got radical x. I'm going to do g of f, so I'm going to take f and plug it into g. So in other words, wherever I see x, I'm going to write x squared minus x minus 6, which gives me then the square root of x squared minus x minus 6. Now this graph's not so obvious what it looks like, so we're going to have to do this algebraically. Now when you're doing these algebraically, there's a couple of things we want to look out for. Certainly we can't do any negative square roots because we're going to get something imaginary. So what that means is anything under the parentheses, anything under the radical must be positive, or another way of saying that is it must be greater than or equal to 0. So we take whatever inside the radical, set it greater than or equal to 0, and then we go ahead and solve. So this goes back to your topic that we did on quadratic inequalities. So first of all, notice this factors. And I knew straight away that this was going to be the correct answer, but if we draw a little picture, so we don't have to guess, I know my answers are the opposites for this, so negative 2. And opposite for this one, positive 3. X squared we know is a nice U shape. And where it's greater than 0, we're looking here and here. So notice it's to the left of negative 2, so less than or equal to negative 2. Notice it's the right of 3, so x is greater than or equal to 3. Now I put my range straight away as y is greater than 0. Where did I come up with that? Well, I'm looking what values I can get for this. When I do a square root, I'm always going to end up with something positive because I'm not allowed any negative answers. Or I could end up with 0. If this was equal to 0, the square root of 0 is 0. What about the largest value? What's the largest value I can get in here? Well, x squared minus x minus 6 we actually just drew a second ago. And notice this continues up to infinity. So basically, x can be infinitely big. And if we do the square root of something that's infinitely big, it's still infinitely big. So actually it goes from 0 to infinity. But these take a little bit more thinking about. Actually, this would have been more interesting from this question if this graph would have been upside down. If there had been like a highest value, so supposing the highest value had been like at 4, then actually the range for this question would have been between 0 and 2. Now the reason I say 0 and 2 is if the highest value this can take is 4, when I do the square root of 4, I'm going to get 2. So for this question, this was fairly easy to work out, but we might end up with questions that are slightly more difficult to work out. Now the other thing that I don't have on here, but could appear in your exercise, is one other case as well, is if we're dividing by 0, that's also a problem. So if I was to give you a question like this, with a fraction, the denominator is never allowed to equal 0, because 1 divided by 0 is undefined. So anything with fractions, we need to make sure our denominator is not 0. So all we do is take our denominator and say that it must not equal 0. And then go ahead and solve. So if we add 3 to both sides, x cannot equal 3 would match our domain for this question. Range for this one, we could also use a transformation for this graph. Notice this is the graph of 1 over x that we had earlier, but it's been moved 3 places to the right. So as we already know the range for that answer, we could figure out the range for that question as well.